Hi, are you ready for another video where I discuss further questions, numerical questions from the first chapter, Charges and Electric Field, from Class 12 CBSE Physics. Let's start with the first question for the day. Today's questions discuss about dipoles. As a result of that, this first question is about a dipole. So there is an electric dipole. Now this dipole is kept inside an electric field, and while it is placed, it is making an angle of theta equals 60 degree with the electric field. Now the electric field would have a strength, right, which is given by E equals 4 into 10 to the power 5 Newton per Coulomb. We would have already studied that when I keep a dipole inside an electric field, an uniform electric field, and I keep it at an angle of theta, it results in a couple, and a couple causes torque. So in this case also there is a torque, tau, given by 8 into root 3 Newton meter. Now the length of the dipole, we use always the convention 2a for that, is given by 4 centimeter. Now the question is to find the charge of the dipole. Now let's visualize this, how it would look like. So if I have to imagine the electric field, so you can imagine an electric field like this, and within that we have a dipole. Okay, so one end of that is let's say keep it as plus q, the other one is minus q, and it is making an angle of theta with the electric field. Now we want to find the value of plus or minus q. This is straightforward. We know the formula for this. Torque on a dipole is given by tau equals P E multiplied by sine theta. Now what is P? That is dipole moment. Now dipole moment is nothing but Q into 2a. Now when you substitute back in this, tau equals Q into 2a into E sine theta. Now we are looking for Q. Can we keep just Q on this side and transfer everything else to the other side? 2a into E multiplied by sine theta. I think we have every required value to solve this question. Now let's substitute 8 root 3 for tau. 2a is 4 centimeter. I'm going to write it as 410 to the power minus 2 meter. Then E is given as 410 to the power 5. And then finally, we have sine theta. Sine theta is root 3 by 2. Now we solve for this. We get 10 to the power minus 3 Coulomb. Or I can write it as 1 millicoulomb. Let's go to the next question. So we again have a dipole here. Now the charges of the dipole, we know that there will be a minus q and plus q. So it is at minus 4 microcoulomb, and this is plus 4 microcoulomb. Now this dipole has two endpoints. Okay, imagine like this. So it has a point A, point B. Now you have to think of a three-dimensional Cartesian system, not a two-dimensional one. So when I speak about a three-dimensional Cartesian system, so you are going to have I, J, K, or XYZ values for XYZ coordinates for every point on this. So A and B exist in a three-dimensional system, and they have given the value of A as 1, 0, 4, and B as 2, -1, 5. Now this dipole is present in an uniform electric field, which is given by a vector. Okay, remember this is a vector, 0.2 into I cap, and this is given in volt per centimeter. This dipole is creating a torque. The torque value is tau is 8 into root alpha into 10 to the power -5 Newton meter. The question is, what is alpha? That is what we are interested in finding out. Now let's look at the values which are given here for a moment. So electric field, we are usually looking at values expressed in coulomb. However, in this case, they were expressed in volt per centimeter. Now what do we do? Volt per centimeter, if we could convert this into volt per meter, is nothing but 1 Newton per coulomb. So we can convert electric field resulted expressed as volt per meter to Newton coulomb. Okay, this is a direct conversion. Now let's go back to this this setup we have. So we have these two different points. Now what I could do is I can create a vector called L vector, so which is nothing but the line that is connecting these 2 points in space. That is L vector. Now L vector, I can represent it as I2 minus I into I cap plus J2 minus J into J cap plus K2 minus K into K cap. So it is very simple. What I'm saying is A into I cap plus B into J cap plus C into K cap. This is the format which I'm following. This is how we represent a vector in three-dimensional space. So we multiply the magnitude of a vector by any unit vector in that direction. So if I want to write a vector, I have to write it as A dot I cap. That is how we write an A vector. So this is the format which I follow. Now if the A vector had different it is split into 3 coordinates, then we'll write as A1 I vector plus A2 B cap, A1 I cap plus A2 J cap plus A3 K cap. Now we have the values of I2. So this, keep this as 1, this as 2. So I2 is B is I coordinate, X coordinate, minus 1 into I cap plus minus 1 minus 0 into J cap plus 5 minus 4 into K cap. If you simplify this, this is I cap minus J cap plus K cap. This is L vector. Now what is this L vector? This L vector is giving me the direction as well as the magnitude of the line that is connecting the 2 charges of the dipole. Now let's go back to the calculation of torque. If I express it as a vector, torque vector is given by the force and the moment. So in this case, P vector into E vector. This is what torque is. Now if I want to, the moment is P vector. Now if I could split that, so charge multiplied by the length. Now charge, I will represent it as a scalar, and there is a vector quantity L vector multiplied by E vector, right? So which is Q into I cap. So we have the value here, right? So we duplicate it. This is I. And E vector. So what is E vector? We know that E vector is given as 0.2 volt per centimeter. That is 0.2 by 10 to the power minus 2 volt per meter, or 0.2 by 10 to the power minus 2 Newton per coulomb. So if I substitute the value, the value in this, so you get 0.2 by 10 to the power minus 2, and then there is also a vector along with this. So this vector is represented I cap. So I also have I cap in this. Let's go on and calculate this further. Q into I cap minus J cap plus K cap into I cap multiplied by 20, and Q is 4 into 10 to the power minus 6. So if you do that, you get 8 into 10 to the power minus 5, and then I cap cross I cap minus J cap cross I cap plus K cap cross I cap. Now this is very important. So I am not mentioning it as a dot or an asterisk. I am very particular about mentioning it as cross. So this is where the idea of how we multiply vectors come into the picture. So when you multiply unit vectors, so we are speaking about 3 different unit vectors, right? I cap, J cap, K cap. Now there are 2 kinds of multiplication of unit vectors possible. One is dot, the other one is cross. A dot multiplication would give you a scalar quantity, and a cross multiplication would give you a vector quantity. In this case though, we are concerned with a vector quantity because the product which I get, this product which I get, this should have a direction. It should tell me the direction in which the torque is acting. So as a result, this is a vector quantity. So I'll be using vector. Nevertheless, let's look at how do we do the multiplication. So I cap dot I cap, or if I multiply J cap dot J cap, or if I multiply K dot K, in all these cases it is 1. Now if at all I reverse, if I change instead of I multiplied by I change it to I multiplied J, or J dot K, or K dot I, all of them equal 0. Now this is dot product. Now let's speak about cross product. Cross product, so the same idea. Now let's move it here as expected. So I am not going to have dots here. I'm going to have cross here because it is cross product. In all these cases, it is 0. Then now let's look at the other multiplication. I cross J would give you K. J cross K would give you I. And K cross I would give you J. This is cross product. Now if I change the order, if I change J cross I, then I'm going to get a negative sign. This is minus K. So that is the idea of dot product and cross product. Now let us come back and apply this idea here. So 8 into 10 to the power minus 5, I cross I should give us, I cross I should give us 0. J cross I should give us minus k, so it becomes plus. Plus k cross I would give us j cap. So this is the vector we have. Now we don't just want the vector. I want the value which is tau, magnitude of tau. Now how do we get magnitude of a vector? Now let's do another calculation. A vector is given as a1 I cap plus a2 j cap plus a3 k cap. Now if I want to calculate the magnitude of this vector, I could do that. Magnitude of this vector is given by square root of a1 square plus a2 square, a1 square plus a2 square plus a3 square. This is how we calculate the magnitude of the vector. Now in this case we have tau whose value we already know, 8 into 10 to the power minus 5, and I want to calculate the magnitude of this. 0 square we're not going to consider, 1 square plus 1 square. If you do this, we get 8 into 10 to the power minus 5 root 2. However, tau value they have already given us. This is nothing but 8 into alpha root alpha by 10 to the power minus 5. That means we are looking at alpha. This is alpha. Actually, square root is not alpha. Alpha is 2. That is the answer we are looking for. Let's go for the next question. In this question also, we are speaking about a setup. And in this setup, there is a dipole. And every dipole would have equal and opposite charges. So I am saying it is 5 microcoulomb. 5 microcoulomb. And the length of the dipole is 2a, which is 4 centimeter. Now we are taking an axial location, right? So when we speak about axial, so we have a dipole like this, keeping a dipole like this. So this is a midpoint center origin. From here I'm taking some point at 4 centimeter. I want to find the value of E from here. Now I'm assuming that this is Q, this is minus Q. So what will be the force that will be acting? So this force is going to act in this direction, right side, because the electric field tends to move from the negative charge to the positive charge. Now what is the axial electric force? So because it passes through the axis, so the axis of the dipole, if you look at, would be like this. So this point, whatever we have, is also passing through the axis. That's why it's axial electric force. Now axial, there is a direct formula, 1 by 4 pi epsilon naught into 2 pr by r square minus a square whole square, which is 1 by 4 pi. No, okay, so instead of 1 by 4 pi epsilon, I could frequently eradicate and convert it into K, Coulomb's constant, which is equal to 9 into 10 to the power 9. So we go for 9 into 10 to the power 9, 2 into PR, I could change into 2a into q, that is the dipole moment. So q is 2a is 4 centimeters. So I'm going to do this 2 into 10 to the power minus 2. Oh, sorry, this is 4 centimeter. 4 into 10 to the power minus 2. Then q is 5 into 10 to the power minus 6. Then we also have r. R is also 4 into 10 to the power minus 2. So where is r? Okay, this is r. 4 into 10 to the power minus 2. Now in the new denominator we have r square, which is 0.04 square minus a square 0.02 square whole square, and it's a matter of just solving. When you solve, you get 10 to the power 8 Newton per coulomb. So axial force is 10 to the power 8 Newton per coulomb.